Hi, today we are going to be taking the derivative of arcsin x equals y. Alright, so I know you can use your traditional formulas that you find in the textbook and whatnot, right? But I think it's always good to know where these formulas come from, and if you forget them on the test, you can always refer back to this method. It is a little bit longer, but it definitely works for all situations. So we have this original formula, and anywhere you have an arc, you can rewrite it as this, because these two things mean exactly the thing, because this is just the inverse of this, right? And you know, in doing inverse, you just switched x and y values, so that's all that we've done here pretty much, and got rid of the arc, which means the inverse. Anyways, moving on, we have this, which means that the sine of angle y equals x, right? So we can draw a triangle with an angle y, opposite of x, and a hypotenuse of 1. And we know that our adjacent is going to be 1 minus x squared then. And then what we're going to do is we're going to take the derivative of this, which is going to turn into cos y dy by dx. Now this is using implicit differentiation, equals 1, right? Now we're going to continue on, and we're going to use our triangle to solve for what cos y is. So seeing this, we see our angle y, and the cos of that is going to be adjacent over hypotenuse, which is going to be 1 minus x squared over 1. So subbing this in for cos y into our formula, we now get 1 minus x squared times dy by dx equal to 1. And now we can just solve for dy by dx equal to 1 over the square root of 1 minus x squared. And if you look in any of your traditional formulas, you'll see that that is exactly what it should equal. And in my next video, we are going to look at a more difficult one, arctan of 2x, where you get some trick stuff in there. Anyways, yeah, thanks.